Hey guys! Okay, so I'm going to explain another method that you may have used to solve this problem. This is method number 2. You're given a cone, you're given the height of the cone, you're given the volume of the cone, you're asked to find the radius. So what we did in the last problem was we wrote down the volume formula. Oops, that is not the volume formula. The volume formula for a cone. So we have the area of the base, which is a circle, okay, times the height of the figure, and we divided this by 3 because when we have a one-based figure, like a cone or a pyramid, we know that the volume of that figure occupies a third of its counterpart, whether that's a prism or a cylinder. And we remember that water experiment from class when we filled a cylinder with the water from a cone that had a congruent circular base, and it only filled the cylinder a third of the way. So then we, in the last method, showed how we plugged in our given values. So we know that the volume is 550 cubic feet. We don't know the radius. That's what we're trying to find. Okay, we want to find this. We know that the height is 21 feet, and we're going to divide all this by 3. So what we did in the last video was we found what is the value of pi times 21 divided by 3. We're not going to do that this time. We're going to use a different method. Same thing, okay? Order of operations tells us same thing. We have this value divided by 3. We're going to multiply both sides of our equation by 3. We're multiplying this side of the equation by 3 because we know that when we perform the inverse operation of what's happening, so we have this chunk being divided by 3, we're going to multiply by 3. We then have 3 divided by 3, which reduces to 1. Or you guys like to say it cancels out. Technically, this is reducing to 1. So this all goes away, okay? Whatever we do to one side, we have to do to the other. That's why we multiply the left side by 3. Then we're going to simplify our values. So on the left-hand side, I just had to cheat and use my calculator, 1,650 feet cubed equals what was left in the numerator here. So pi times r squared times 21. So you could, at this point, again, look for all of the numeric values, so parts that aren't variables or unknowns on this side. You could do pi times 21, find that value, and then divide out that value. Or you could say, hey, I'm going to recognize that pi times r squared is being multiplied by 21. I need to get rid of this 21 to make my life easier. So I'm going to divide both sides by 21. 1,650 divided by 21 equals, ooh, that's going to be a nasty decimal. Hang on. 78.57 or 57 hundredths equals 21 divided by 21 reduces to 1 equals pi times r squared. Actually, something that I could have done, and I'm going to go back, instead of writing 1,650 divided by 21 as a decimal, I'm going to keep it in fraction form. This fraction reduces to 550 divided by 7. Why am I doing this? I want to find the exact answer for this problem. I don't want to have to do any rounding with decimals. I'll leave it like that, okay? My next step would be to recognize that r squared is being multiplied by pi, so we need to divide out that pi. So this whole value divided by pi, I'm going to bring the work up here. 550 divided by 7 divided by pi is the same thing as 550 divided by 7 pi. That's going to equal r squared, okay? So I just divided both sides by pi, and this whole value right here is just going to be some number. Then I'm going to find, oh, actually, I am going to write this as a decimal. Yeah. So I'm going to reduce this right now to a rounded decimal form. So 550 divided by 7 times pi equals, my calculator gives me exact answers. That's annoying. Same thing as the last problem, 25.01. 25 and 1/100th equals r squared. Side note, when you're plugging this into your calculator, the important thing to remember is, okay, so if you have 550 and you're dividing this by 7 pi, we want to put 7 times pi. Oh man, hang on. 7 times pi, we need to put in parentheses. So we know that this 550 is being divided by 7 pi. If we had done this, 550 divided by 7 pi, your calculator may have thought that you did 550 divided by 7 and then times pi, which would give you a completely different number. So we want to make sure that pi is what 550 is being divided by. It's in the denominator, not the numerator. So if I were to write this, we want to make sure that we have 550 divided by 7 times pi, not 550 divided by 7 and then this whole value times pi, where pi is in the numerator. We do not want this, okay? So then we have the same thing as before. We have r squared equals 25. We don't want to know r squared. We don't want to know the radius squared. We just want to know the radius. So again, to isolate this variable, we need to perform the inverse operation of what's happening to it. So if this unknown value r is being squared, let's take the square root of it so that this cancels out. Be left with r. Whatever we do to one side, we must do to the other side. The square root of 25.01 is about 5. R equals 5. And you can check method number 1 to see how when you plug this value of the radius back into this equation, you get a true statement. You get 550 equals 550. If you got any value other than 550 on this right-hand side, so let's say you thought that the radius was 3.2 for some reason, and you plugged that into this equation, you would not get a true statement. Your left-hand side would not equal your right-hand side. You would know that you did something wrong along the way, and you would have to go back and check your work, which is always super fun to do, especially if you did this test question in Sharpie or like permanent marker instead of a pencil with an eraser. Good work.